All right, ladies and gentlemen, we are going to take a look at the 8-2 notes. We're just continuing our journey through the rules that apply to powers and kind of learning when do I add them, when do I multiply them, and today we're going to learn when do I subtract them. So in the original problem here, I'm going to be dividing. If you remember, in the previous week, we learned what if I have something to a power multiplied by that same base to a power. What do I do with those in that scenario? I keep the same base and I add my powers. That was one thing we learned. Then we learned what if I have a base raised to a power and then that is raised to another power. In that scenario, we ended up multiplying the powers together and getting a to the 8 in that way. So what we're looking at today is what if instead of being multiplied or raised to a power, our original problem is division or appears like a fraction. Think about what each of these means. A to the 5th means 1, 2, 3, 4, 5 A's. A repeated or multiplied by itself 5 times. On the bottom of this example, I have a to the 3rd power, so 1, 2, 3. When you space it all out like that, each of these cancels one from the top, cancels one from the bottom. That leaves me with a times a, but a times itself is a squared. But an easier way to get there directly would be to think of it in terms of subtraction. Now, I always think of it at the high school level. I always talk to them about looking at the two powers, figuring out what's the difference. The difference between 5 and 3 is 2. I had more to begin with up top because there were 5 up top and only 3 on the bottom. So those 2 extras end up on the top of my fraction. Now, in this case, there weren't any left on the bottom. So it would technically be over 1, but you don't have to write things over 1. You can just write it as a to the 2nd, which implies that it's over 1. So this is just going to be another new rule, but all the other rules still apply. So the fancy way of saying this rule is the quotient of powers property, but think about what quotient means. It means the answer to a division problem. So again, that's how you know you're in this situation, is it looks like a division problem. You're going to be subtracting the powers because they're basically canceling one another out like they did up here. We just went through and said these 3 on top cancel these 3 on the bottom. The difference, and in math we find difference by subtraction, is that there will be 2 left over, the difference between 5 and 3. So let's look at some examples, and as we get to the bottom, they start to have examples of what we've learned in the past combined. So we really have to kind of think that through. So in this case, my base is 8 in both cases. I have 10 on the top, 4 on the bottom. So I think, what's the difference between 10 and 4? The difference is 6. The greater number of 8s is on the top. So all of these cancel, leaving me with just 6. So 8 to the 6th power is my simplified answer. Now, don't panic because of the negatives. It doesn't really matter what the base is. And I know this whole thing is base because the whole thing is raised to the power, because it's showing me with parentheses, -3 to the 9 and -3 to the 3rd. So I have 9 -3s on the top. I have 3 of them on the bottom. So the difference would be 6. And that would be my final answer. Okay, now we have to kind of go through and figure out how to do a problem that has multiple steps to it. I usually go through my problems and I do anything that's outside of parentheses. So if I have a power outside my parentheses, I'm going to multiply that in first, so that in that scenario, my powers are multiplied. Then I do neighbors. So I just call them neighbors because they're going to be next to each other. So I would have like a base to a power times that same base to another power. And I would go ahead and add those together. And then for me, the next thing that I do, so this one was adding, the next thing that I do is do the canceling or the dividing that we're learning today. That's always the last step that I do. I am struggling with writing that word neatly. And so in that scenario, I'll subtract. So in this number 3, I don't have parentheses, so I move on, and I like to look across and say, okay, 5 to the 4 times 5 to the 8 means I have 5 to the 12, because I would have had 4 5s here, 8 5s here, a total of 12. And that's my neighbors. Now I go and cancel from top to bottom, which is going to be subtraction, thinking 12 and 7. So I have a base of 5. I have 12 on top minus 7 on the bottom. So the difference is going to be 5. So my final power is 5. This one looks kind of tricky, and sometimes it's better to rewrite it. When you have a whole value like x to the 6th, I can write it over 1 to make it look less weird. And then I can treat the whole top as one top, so 1 times x to the 6th, and the whole bottom, so that would be 1 times x to the 4. Well, 1 over 1 is just 1, and then I can just focus on this part, saying, okay, I have 6 on the top, and then I have 4 on the bottom. So the difference of those, I shouldn't write it that way, sorry. I have 4 on the bottom. So the difference of those two powers is going to be x to the 2nd. So something like this that doesn't look like a power can be written over 1, doesn't look like a fraction. It can be written over 1 to remind us that we can then treat the tops as one top and the bottoms as one bottom. Nothing weird about this one. This one's actually pretty straightforward. This one's saying, hey, I have a base of 6, 11 on the top, 5 on the bottom, so the difference would be 6. And again, that's just because if I wrote out all 11 6s on the top and all 5 6s on the bottom, 5 of them would cancel out, leaving me with 6 extras on the top. Here I have parentheses, so I'm going to think back to what I kind of put here as my 3 things that I go through. And the first thing that I like to do is the parenthesis. And this power, because of the parenthesis, gets multiplied by all the powers that are in there. This b doesn't have a power written, so it's to the power of 1. And so that 5 power is going to get multiplied by both. So I end up with a to the 2 times 5 over b to the 1 times 5. So I get a to the 10 power on the top and b to the 5th. Now I can't do anything else. I can't cancel, I can't combine, because they have different bases. One is an a, one is a b, so they don't really intermingle, they don't cancel, they don't add, they don't do anything. One thing that I always use when I'm talking to my high school kids is I always tell them to check their answer. And you want to make sure that you have no repeat bases. Meaning I shouldn't have a written more than once anywhere in my problem. I shouldn't have x more than once, m, n. So like in number 8, I know this problem needs work because m is written in 2 different places. So I check my answers. And so here I have an a and a b. I don't have any repeated letters. So that's a good sign. Now this one's kind of tricky because everyone's favorite answer to put wrong is 12. When I distribute this, I'm multiplying the 3 by the powers. 4 is currently to the power of 1. So I don't multiply the 3 by the 4, I multiply the 3 by the power of 1 that was already there. Just like with the x, I multiply that power of 2 that was already there by the 3 that I'm bringing in. Same with the 5. I'm going to have 5, which was to the first power, get multiplied by a power of 3. My y was also to the first power because anytime there's not a power written, it's a 1. And this 3 is getting multiplied by all the powers in there because of the parentheses. It's getting distributed basically to every single power. So you don't have to write the 1s. I'm just showing you. So this would turn out to be 4 to the 3rd. X to the 6th. I'm just going through and multiplying the powers I wrote out. 5 to the 3rd and y to the 3rd. I do not have any letters repeating. I have an X and a Y. And then I can just leave this as is. I don't have any bases that are the same. This has a base of 4, base of 5, base of X, base of Y, no repeats. There's nothing else I can do. Here, I don't like them to be two separate fractions. It gets me kind of confused. So you can take all the tops and write them as one top as long as they are multiplied, which these are. So 3m to the 4. On the bottom, I have an 8, an m to the 5, and then an n to the second. 3 over 8 does not reduce or simplify, but m to the 4 and m to the 5 can. But this one's kind of tricky. I have to go back and think about, canceling these out. 3 and 8 don't reduce, so 3/8 is just going to stay. But if you look at this, the difference between 4 and 5 is 1. But the 1 would actually be left on the bottom, not the top. Here's why. If I wrote this out, m to the 4 means m 1, 2, 3, 4 times. And then on the bottom, I have 8 and then m to the 5th. So 1, 2, 3, 4, 5, and then my n to the second. These are going to cancel, and that extra one is going to be on the bottom because that's where the higher power was. And then there's nothing to cancel, reduce, or change the n because there's no other n's. So my answer is left like that. I like to go through and do each thing separately. I look at the I look at the numbers, and I'm like, okay, can't do anything there. Then I look at the next letter, which for us was the m's, and I did my work. Then I look at the next letter, which was the n's, but there's nothing I can do because there's nothing else to intermingle or mix with that. So these are not mathematically hard, like solving, but they are a lot of little details to keep track of. Okay, this one's going to be tricky, so let's think about this one. So this means that my -5 is going to get squared, which means multiplied by itself. This is going to get squared because this was a 1. So I end up with x to the 1 times 2 power. Here, I have a 2, an x to the 4, and a y to the 3. I don't have to deal with anything else yet. Alrighty, let's take one thing at a time. Let's take the numbers. So my numbers are -5 times -5 times 2. I'm treating the whole top as one thing. So -5 times -5 becomes +25 times this 2 becomes a 50. So that's just multiplying these numbers together. Now, I have an x to the 4 on the top, but I have an x to the second on the bottom, and then my y cubed. So I wouldn't be done because if I check my answer, I do have repeat bases. I have x in 2 different places. So I look at that and I say, okay, 4 on the top and 2 on the bottom. Between 4 and 2 is a difference of 2. And because I had more to start with on top, those extra 2 x's end up on the top. The y cubed just stays at the bottom doing nothing because there were no other y's for it to interact with, cancel, add with, nothing. And our grand finale, geez Louise, that is a big one. Without parentheses, there's nothing that I have to do to this one yet. Here, this needs to get squared because it's currently to the 1 power. So keep in mind, it doesn't become 2, it becomes 1 to the 2nd power. And here, I multiply by the power, so 2 times 2 becomes x to the 4th. If I treat the top as one thing, I would have 1 squared, which is 1, times 3, which is 3. X to the 3rd. On the bottom, I have, for a number, I have a 2. I'm going to put them in alphabetical order just so they line up. For x's, I have x to the 4, and then I have a y. But I'm not done because if I check my answer, I can have no repeat bases, and I have one. I have the x written in 2 different places, here and here. So I use the rule that I learned today. And again, this one's kind of tricky because the extras will actually end up on the bottom. because you have 3 on top. So if you want to think about what that looks like as repeated multiplication, and then you have 1, 2, 3, 4 on the bottom, when you come along to cancel these, you're going to have this one, and this one canceling, and that extra one's going to be on the bottom because that's where the higher power was. So the 3 and the 2 do not reduce. This is completely gone, but it leaves me with 1x on the bottom. And then I still have that y sitting there, but there are no other y's for it to interact with. So when you're going through these, you really have to kind of just take it one step at a time, and they're going to be more than one step. Look and see, is there a power I need to deal with outside of parentheses? Do I have any of the same letters, numbers, or bases sitting next to each other where I should go ahead and add their powers, combine them? Do I have any of the same letters, numbers, or bases on the top and bottom that I should cancel or reduce using subtraction like we learned today? And when I'm done, can I look through my answers and say, I know that I have no repeat bases, meaning X is not written twice, M is not written twice, Y is not written twice in those final answers that I'm getting. So this is a good brain activity. It takes a lot of concentration to really get all those catchy little tricky details. So watch what you're doing and watch the video again if you need some more help. Have a good day, guys. Bye.